Hello everyone, myself Mr. Kiran S. Chinswalkar, lecturer in Mechanical Engineering Department from Praveen Patil College of Diploma Engineering and Technology. We are starting chapter number 4, Forming Processes, part 2, Learning Outcome. After watching this video, you will be able to know open die and closed die forging operation. Second, closed die forging operations. Third, principle of rolling. Fourth, types of rolling mills. And fifth, different methods of extrusion. Now we study open die, closed die forging operations. Forging die is constructed from high-grade carbon or alloy steel and must resist heat, abrasion and pressure. They must withstand severe strains, have a longer wear life under high production conditions. Forging dies are essentially of two distinct different designs. First is open die forging and second is closed die forging. In this slide, we study open die forging. In this process, two flat dies are used. Therefore, accuracy depends upon the skill of the operator and space between the two dies, which is known as a fin. The same dies could be used for producing wide variety of parts. If open die is used in a hammer, the process is called hammer forging. If open die is used in a press, it is called press forging. If open die is used in a smith forging by hand on anvil, the process is called hand forging. The operations on open die forging are upsetting, drawing out, bending, piercing and spreading. Figure 4.2 shows 4 stages in open die forging. As the hammer drops, the material starts flowing in both horizontal and vertical direction. Since there is no restriction to flow of the material in a horizontal direction, the vertical flow will be very low compared to the horizontal flow. In figure 4.2, hollow punch is used just to show that material does not fill the punch gap fully as it does if you use closed die. The main advantage of open die is it is very low cost. In this slide, we study closed die forging. Working principle of closed die forging. In closed die forging, cavities or impressions are cut in the die block, in which the metal is forced to take its final shape and dimension. The flow of metal is limited by the surface of the impression. This forging makes good utilization of workpiece material. The grain flow of the metal is controlled to ensure high mechanical properties. Figure 4.3 shows 4 stages in closed die forging. As the top die, called as a punch, comes down in the downward stroke, the billet, that is forging material, flow in both horizontal and vertical direction. The vertical height filling is no problem as observed in open die forging. In this slide, we study dies used in closed die forging. Dies used in closed die forging may be classified as single impression die and multi impression die. Single impression die. This die contains only one cavity or impression, which is the finishing impression. The preliminary forging operations are done by hand or on forge hammer, forging rolls, etc. And only finishing operation is done in die cavity. Second die is multi-impression die. The first point, this die contains finishing operation and one or more auxiliary impression for preliminary forging operation. Second point, the final shape of the part is progressively developed over a series of steps from one die impression to the next. Third point, generally multi-impression dies are very expensive to make and are employed only when the quantity to be made is sufficient large. Now we study closed die forging operation. Basic closed die forging operations are fullering, aging, bending, setting down and finishing. These are four operations which are performed in a closed die forging operations. Now we study first operation, this is fullering. First point, it is the operation of reducing the thickness of the workpiece. In this process, the bottom fuller is held in the hard die hole of the anvil and heated workpiece is placed over it. Then the top fuller is placed over it and the hammering operation is carried out till the piece gets required thickness by moving the job to and fro. Tool used for fullering is called fuller. Next operation is aging. First point, the function of aging or rolling operation is to distribute the metal longitudinally by moving metal from the portion of the stock where it is in excess to the portion which is deficient in metal. For example, for forging a connecting rod from the bar stock, the metal will have to be moved longitudinally since the section of the rod varies along its length. Third point, this is an important operation in closed die forging. Next operation is bending. First point, bending is done to produce different bend shapes such as angles, ovals, circle, etc. or any desired curvature. Second point, for making right angle bend, that particular portion of the stock which is to be subjected to bending is heated and jump on the outer surface. Point number 3, this provides extra material at that particular place which compensate from the elongation of the outer surface due to hammering during bending. Fourth point, the operation is carried out on the edge of anvil or the perfectly square edge of a rectangular block. Next operation is setting down and finishing. Setting down is the operation through which the rounding of a corner is removed to make it square by means of set hammer. Second point, the face of the set hammer is kept over the round portion formed by fullering or bending and hammering it at the top. Now we study principle of rolling. The process of rolling basically consists of passing the hot ingot through two rolls rotating in an opposite direction at a uniform peripheral speed. The space between the roll is adjusted to confine the desired thickness of the roll section, and the same is always less than the thickness of the ingot being fed. The roll thus squeezes the passing the ingot to reduce its cross section and increase its length. The diagram shows the changes in a grain structure as it passes through the rolls. As a result of squeezing, the grains are elongated in the direction of rolling and the velocity material at the exit is higher than at the entry. After passing the stretch zone, the grains start refining but tend to retain the shape acquired during rolling. The rolls are in a contact with the passing material piece over sufficient distance represented by arc AB in diagram. The angle of AOB subtended at the center of the roll by the arc AB is called angle of contact or the maximum angle of bite. Now we study application of rolling. Application of rolling. First application is different types of shapes are formed such as I section, T section, L section, channel section, etc. Second point, special sections such as railway wagons wheels is produced by rolling. Third point, bars of all shapes, rods, sheets, etc. Fourth point, several metals are rolled into variety of shapes. Now we study hot rolling. First point, before metal can be mechanically worked, they are cast into ingots. Second point, these ingots are changed of rectangular, square or round in cross section of various sizes which are called as the billets. Third point, the billets are pressed through rolls to reduce their size at a temperature more than recrystallization temperature is called as a hot rolling. Fourth point, the large number of useful articles such as plates, bars, structure section like T section, I section, channels, etc. are produced. Now we study cold rolling. First point, a cold rolling is a rolling of metals below its recrystallization temperature. Second point, the same type of rolling mills as it is used in a hot rolling can be used for this. Some extra advantages obtained with cold rolling are: point A, it produces oxide-free surface. Point B, the surface produced is smoother and bright. Point number C, close tolerance can be achieved. Point number D, toughness and tensile strength increases due to work hardening. Point number E, hardness also increases. Often, first metal is hot rolled and then it is finished by cold rolling in order to get above stated advantage. Bars, rods, sheets, plates, etc. are cold rolled. In this slide, we study types of rolling mills. Types of rolling mills are: first is 4 high rolling, second is 2 high rolling, third is 3 high rolling, fourth is cluster mill, and fifth is continuous rolling mill. First types of rolling mills is 2 high rolling. It consists of two heavy horizontal rolls placed one over the other. The rolls are supported on bearing housed in sturdy upright side frame called stands. The space between rolls can be adjusted by raising or lowering the upper roll. The position of lower roll is fixed. Both the rolls rotate in an opposite direction one to another. Their direction of rotation is fixed and cannot be reversed. Thus, the work can be rolled by feeding from one direction only. 2 high roll mills is normally employed for initial rolling of an ingot. Now we study 3 high rolling mills. It consists of 3 horizontal rolls, positioned directly one over the other. Direction of rotation of the upper and roll loads are the same, but intermediate roll rotates in a direction opposite to both of these. All the 3 rolls continuously revolve in the same fixed direction and are never reversed. The workpiece is fed in one direction between the upper and middle rolls, in the reverse direction between the middle and rolls. Many pieces may be passed through the rolls simultaneously. This results in a higher rate of production than the 2 high mill. This mill may be used for blooming, billet rolling or finish rolling. Now, in this slide, we study 4 high rolling mills. It consists of 4 horizontal rolls, 2 of smaller diameter and 2 of larger diameter, arranged directly one over other. The larger diameter rolls are called backup rolls, and their main function is to prevent the deflection of smaller rolls which otherwise would result in thickening of roll plates or sheets at the center. These smaller rolls are known as the working rolls, and they are the rolls which concentrate the total rolling pressure over the metal. These mills are generally used for subsequent rolling of the slabs. The common product of this mill are hot or cold roll sheets and plates. Next types of rolling mills is cluster mill. It consists of 2 working rolls of smaller diameter and 4 or more backup rolls of larger diameter. The number of backup rolls may go up as high as 20 or more depending on amount of support needed for the working rolls during the operation. This type of mill is generally used for cold rolling. Next types of rolling mills is continuous rolling mills. First point, it consists of a non-reversing 2 high mills arranged one after the other so that material can be passed through all of them successfully. Second point, the roll of each successive mill stand rotate in a faster speed than that of the preceding roll in order to accommodate the increasing length of metal piece being rolled. Third point, this arrangement facilitates very rapid production because the component passes continuously from one stand to the other until it reaches the final pass. Fourth point, but this is suitable only for mass production. Point number 5, for smaller quantities, quick changes of set will be required and it will consume lot of time and labor. Point number 6, as the speed of rolls on each successive stand varies, it is necessary that their respective surface speed should be calculated carefully. Now we study principle of extrusion. Extrusion may be defined as the manufacturing processes in which a block of metal enclosed in a container is forced to flow through the opening of dies. The metal is subjected to plastic deformation and it undergoes reduction and elongation during the extrusion. The principle of extrusion can be understood with the help of simple example. Squeezing toothpaste from a tube. The cross section of the extruded paste represents the area of opening, that is die. The toothpaste inside the tube remains in semi-solid state. There are methods of extrusion. First is the direct or forward extrusion. Second is indirect or backward extrusion. And third is tube extrusion. Now we study direct or forward extrusion. A heated round billet is placed in the container. The dummy block and ram are now positioned properly. As the pressure is applied, the extruded metal comes out through the die. The pressure is withdrawn when nearly 10% of the billet remains in the chamber. This portion is called discard. The length of extruded part will depend on size of billet and cross section of die. The extruded rod is supported on a run-out table. In this process, we can see that the metal is extruded in the direction of applied force, hence it is called as a direct or forward extrusion. Advantages of direct extrusion. Compared with the indirect extrusion, more total force is required. Equipment is mechanically simple in construction. Now we study indirect or backward extrusion. For this type of extrusion, the ram or plunger used as hollow, and as it presses the billet against the back wall of the closed chamber, the metal is extruded back into the plunger. As billet does not move inside the chamber, there is no not friction between them. Therefore, much less force is required to, in comparison with the direct extrusion. More complicated types of equipment is required because the plunger becomes weak due to the reduction in its effective areas of cross section. Advantages of indirect extrusion: 25 to 30% reduction of friction, allowing extrusion of larger billets. Second, an increasing ability to extrude a smaller cross section. Third, less tendency of extrusion to crack as no heat formation takes place from friction. Fourth, container liner lasts longer due to less wear. Fifth, more uniform use of billet ensure that extrusion defect and core general peripheral zone are less. And six, lesser time is required. Now we study application of indirect extrusion. First application is to making tubes, pipes and rods. Second, aircraft parts. Third, channel section, I section, Z section. Fourth, to produce variety of cross-sectional shapes such as circular, square, hexagonal and rectangular. These are application of indirect or backward extrusion. In this slide, we study tube extrusion. It is a common method of hot extrusion of tubes. It is actually forward extrusion methods using a mandrel to form the bore of the tube. First, the mandrel is pushed through the center of the billet and the die, followed by applying pressure on the billet by advancing the plunger. The metal is forced to flow through the opening between dies and mandrel. The operation is performed quite rapidly. The advantages of extrusion. The range of extruded item is very wide. Cross-sectional shape not possible by rolling can be extruded. Second point, no time is lost while changing the shape since the dies can be easily removed and replaced. Point number 3, dimensional accuracy of extruded part is superior of rolling. Point number 4, very large reduction in cross section is possible as compared with the rolling. Point number 5, automation is extrusion is simpler. Point number 6, smaller parts in large quantities can be made. Point number 7, extrusion are lighter, more sound and stronger than casting. Then we see application of tube extrusion. First is working of poorly plastics and non-ferrous metals and alloys. Second, manufacture of session and pies of complex configuration. Point number 3, medium and small batch production of tubes. Point number 4, manufacture of parts of high dimensional accuracy with constant cross section. These are some applications of tube extrusion. I hope you understand this presentation. Thank you.